Hi class, and welcome to part 2 where we're learning how to solve systems of equations. In this lesson here, we're going to be looking at how to solve by substitution. So I can solve a system of linear equations by using substitution. A little review. So what is the solution to a system of equations? Okay, so that is where your two lines intersect. Okay, so where the two lines intersect, and again, remember that it is a point. XY. Okay, so when is there no solutions? That would be if the lines are parallel. And what is happening when there are infinitely many solutions? They are the same line. And we did not explore those two, this one here and this one here, when we were graphing, but we will see what it looks like here. Those will be the last questions we do. Okay, so here's a great question. I know there's something similar on your quiz to this one, so let's see how we would do that. So is 3, -1 a solution to the system? Yes or no? So how to check to see if it's a solution? So that would be saying that this point here is where this line and this line intersect. Okay, so let's check. So how to check that is that would have to be working out for both of them. So we're going to plug it in. So I'm going to take x plus y equals 2. We're going to plug that in. Is 3 plus 1, -1, 2. Well, 3 plus -1 is 2. Does 2 equal 2? So far so good. That could be a solution, but again, you have to check it with both. So let's check it with this one. -2x plus 3y equals -9. Again, I'm going to plug that in. -2 times 3 plus 3 times -1 is that equal to -9. -2 times 3 is -6 plus 3 times -1 is -3. -6 plus -3 is that is -9. -9 does equal -9. So since these are both true, this is a solution to the system. Again, that's a great way once you get your answer to check your answer. Okay, so here's how we go by substitution. Here are the rules. So part 1, you want to solve one of the equations for one of its variables. Now, sometimes those variables are already by itself, like if you have y equals and y equals, then you're just setting those equal to each other. If not, then you just have to make sure you isolate one of the variables by itself. Part 2, here's where it gets the name. You want to substitute the expression into the other equation and solve for the other variable. But then you go to step 3. Once you get that variable, substitute the value into the revised first equation or second equation. Actually, doesn't matter which one you pick. And then step 4, check the solutions in each of the original equations. Again, step 4 is that optional one, but again, you can check your solution so you know you get that 100%. Okay, so let's go ahead and do some examples. So solve the system by using substitution for that first step. Okay, so step 1 is telling me I have to isolate one of the variables. Well, let's look. I'm noticing here y equals 2x. Y is already by itself, so we are good on step 1. We already have one of the variables done. Okay, now step 2. This is where we're going to substitute that into that second equation. Okay, so this one is 7x minus y equals 15. Well, y is equal to 2x, so we're going to substitute that in. So 7x minus, again, I'm always going to put this parenthesis here when I'm substituting something in. And I'm going to distribute it, so that becomes negative. And I know on this one I could have just wrote it or done that math in my head, but if it's anything more than one term, you want to make sure you're distributing that negative. 7x minus 2x is 5x equals 15. So x, and then solving, so x is equal to 3. So that was step 2. Again, step 2, you plug it in, and then you solve for that variable. Now step 3, we got to find the other variable. So again, I'm going to plug it in. Now, this one is the easier math, so I'm going to use that one. So y is equal to 2x. Well, x is 3, so we're going to plug that in. 2 times 3 is 6. So y is equal to 6. So our solution, okay, so solution can be written two ways. X equals 3, y equals 6, or sometimes they have it as a point, because remember, where two lines intersect is a point. So that's at 3, 6. So you can see it either way written. And if you want to with that, step 4 is to check your work. Okay, so if I'm checking my work, it's very similar to what we did with that first one, y equals 2x. 6 is equal to 2 times 3. 2 times 3 is 6, so 6 is equal to 6. So far, so good. Again, remember that you have to check it with both of them. So 7x minus y, is that equal to 15? Well, we have 7 times 3 minus y is 6. 7 times 3 is 21. So I have 21 minus 6 equals 15. And 21 minus 6 is 15. So 15 is equal to 15. Both of them check out, so we know that is correct. For the sake of the length of this video, I won't be checking the answers every single time, except for this one here. So again, that's how you would want to check your answers for that. Okay, so again, that's all we have to do there. Let's go down to the next one. Okay, next example. I want to solve the system by using substitution. Again, we're really lucky here. Y is already by itself, so that is step 1. And don't worry, we will see examples where that isn't always the case. Okay, so step 1 is done. Step 2, now we need to plug it in. So I have 3x plus y. Y is equal to x minus 3. And then that's equal to 13. Well, that's a plus, so I can just drop the parentheses. 3x plus x gives me 4x. Solving for x, we're going to go ahead and add 3 to both sides. 4x is equal to 16. To get x by itself, we're going to divide by 4, because remember, we're always doing that inverse, and x is equal to 4. So now that we have x is equal to 4, we can go ahead and go to step 3, which is solving that other variable. Again, it doesn't matter which one you do. I just always like to pick the easiest one. So y is equal to x minus 3. X is 4. 4 minus 3 is 1. So my solution is the point 4, 1. That's where these lines here are going to intersect. Okay, so those were nice. They were giving us to that. Okay, we're nice where y equals by itself. Okay, let's do a few more examples. Okay, so I have the line 3x minus y equals 17, and I have y equals negative 2x plus 8. So again, step 1 is given for us. Perfect. Okay, step 2. Now we're going to plug in for y. So again, I have 3x minus y equals 17. Y is equal to negative 2x plus 8. Again, make sure we're using those parentheses. Now I'm going to go ahead and distribute. Negative times a negative is a positive. Negative times a positive is negative. Okay, so now we're going to go ahead and combine our like terms. So 3x plus 2x is 5x. To solve for x, we're now going to go ahead and add 8. What we do to one side, we do to that other. So I have 5x is equal to 25. And then to get x by itself, we're going to go ahead and divide by 5. So x is equal to 5. And now that we have that variable, we can go ahead and go to the other step. And again, I'm going to pick the one that's the least amount of math. So y is equal to negative 2x plus 8. X is equal to 5. Negative 2 times 5 is negative 10. So, and negative 10 plus 8 is going to give me negative 2. So then my solution here is going to be 5, negative 2. So this is the point where these two lines intersect. Okay, let's look at this next one. Solve the system by substitution. So this is a great example. Star it, do whatever you need to do, because you're going to have to use this substitution method when you do your written example. So here I'm looking, so step 1, we want a variable by itself. Well, in this case, both of the variables are by itself. We have y equals. Well, again, we want to know where these points intersect, so where they're the exact same. So these y values are going to be the same. So since they're the same value, I can set these equal to each other. So we can just kind of go ahead and go to step 2, because both of these are going to be the variables are by itself. So I'm going to set them equal. 2x plus 1 equals x plus 3. And now we're just going to solve like normal. So I'm going to subtract x. 2x minus 1x is 1x, or just x, so x plus 1 equals 3. And then to get x by itself, we're going to go ahead and subtract 1. So x is equal to 2. Well, now that we have that, let's go ahead and go to step 3 to find that other variable. Again, it doesn't matter which one I pick. That looks like the easier math, so I'm going to pick that one here. Again, x is equal to 2, and 2 plus 3 is 5. So my solution, so where these two lines intersect is going to be at the point 2, 5. Okay, so let's go to this next one. And again, for the most part, that's step 1. The variable will be isolated because that's a nice substitution. If it's not, and you're going to see this one in the next video, those are usually set up for elimination. Okay. So here we go. Solve the system by substitution. Okay, so step 1. This variable is by itself, so that's our step 1. Step 2, we need to plug it in. So we plug it into that other equation. So I have 3x minus y. Remember, that is 3x plus 2. And that's equal to negative 2. Okay, so remember, I have to make sure I'm distributing. So I'm bringing down this first 3x, distributing a negative. And remember, when you distribute a negative, it just changes the sign. So this becomes minus 3x minus 2 equals negative 2. Well, now I'm going to combine my like terms. 3x minus 3x. Well, that gives me 0. So these essentially just disappear. So I'm left with this statement. Negative 2 equals negative 2. So here would cause a lot of panic. And that's why I want to make sure that we see this example. So now we're going to look at this. Does negative 2 equal negative 2? Well, that is a true statement. That's a true. Negative 2 does equal negative 2. So when you get that, what that's telling me is that these lines are the exact same, and that means that there's infinitely many solutions, okay? So these lines are actually the same exact line. Let's check how we can see that. Okay, so again, this isn't that nice y equals mx plus b form. Y equals 3x plus 2. Now this is something you don't have to do. I'm just showing you why that is. Okay, well, let's look at this line right here. Right away, just looking at it, these don't look like the same line. Well, this isn't in y equals mx plus b form. Remember, that's in standard form. So to get this in y equals mx plus b form, we have to solve for y. So to solve for y, I have to move over the 3x. Well, if it's positive on the left, that means it's negative on the right. Okay, now to get y by itself, I need to get rid of this negative, so I'm dividing each term by negative 1. So then we have y equals negative 3 divided by negative 1 is a positive 3, so 3x. Negative 2 divided by negative 1 is a positive 2. So now you can tell that these lines were exactly the same. So you're never going to notice for the most part that the lines are exactly the same, and you're going to be able to say that they're infinitely many solutions. So you're going to want to do the work here. And if you get a true statement, then you know that it is infinitely many solutions because they're the exact same line. Okay, So I'm sure you can imagine where we're going to go with the next example, but let's have a little mystery, see where it goes. So here's the next one, solve the system by substitution. Okay, so that's step 1. That variable is by itself, so we get to go ahead and skip to step 2 where we're plugging that in. So I have 6x plus 2y. So remember, y is equal to 3x plus 5 equals 1. 2 times negative 3 is going to give me that negative 6x. And then 2 times 5 is 10. So very similar to what we saw before, we're combining those like terms. Well, 6x minus 6x, that gives me 0x. 0 times x is 0. 0 plus 10 is 10. So now it's saying 10 is equal to 1. Well, we know that is not true. So this is a false statement. And since this is a false statement, that tells me there is no solution. And remember, with the no solution, again, what that means is the lines are parallel. They're never going to intersect. Okay, so if you want to see they're parallel, again, I'll just show you a little bit why. So again, you have this one here, y equals negative 3x plus 5. Let's get this second one here into that slope-intercept form. So 6x plus 2y equals 1. I'm going to get that x by it, or the y by itself. So again, I just moved the x over. If it's positive on the left, it is negative on the right. To get y by itself, I'm going to go ahead and divide by 2. So negative 6 divided by 2 is negative 3. And then 1 divided by 2 is just 1/2, or you could put 0.5. And again, so here is this line, here is that line. These lines you can tell are parallel because they have the exact same slope. Okay. So again, you don't have to do the work that I did here. This is just showing you why that works out the way it is. So if you get a false statement when you're doing substitution or elimination, as you'll see next, or graphing, if you end up graphing parallel lines, no solution, again, means the lines are parallel, which makes sense because your solution is where two lines intersect, and lines that are parallel never intersect. Okay, so just a little bit of a review. So you need one variable to be isolated, and then you replace just that variable in the other equation to solve. If you get where you have a true state, if the variables cancel out when you're solving, and the statement is true, remember that is infinitely many solutions. And if it is a false statement, that means it is no solutions. And if you get an answer, that means it is one solution. That is the point where the lines intersect. Okay, so that is it on substitution. I hope you join me for the next lesson, which is on elimination.